afternoon. I'm Dave Darwin, Chair of the Civil, Environmental, and Architectural Engineering Department, and I want to welcome you all to the 7th Annual J.A. Tiberti Family Lecture. This lecture series honors J.A. Tiberti, an engineer who founded the J.A. Tiberti Construction Company in Las Vegas, Nevada in 1950. J.A.'s life was guided by strong conviction in truth, humility, and ethics, and over the course of his storied career, he earned a reputation for his remarkable ability to distill a challenge to its core and to provide solutions to his clients with clarity of thought and a straightforward approach. I would like to acknowledge Mr. Tito Tiberti, who is with us today, and who in 2012 gave the second J.A. Tiberti Family Lecture. I'd also like to acknowledge the Tiberti family for supporting this great series, the goal of which is to host accomplished professionals and educators who can inspire students' personal growth and professional development in a way that would have made J.A. proud. Also with us today is Dean Michael Brannicky. Michael, thank you for joining us. Our speaker today is Ronaldo Nicholson, Vice President and Mid-Atlantic Region Manager for Parsons Transportation Group in Washington, D.C., currently providing advisory and program management services for the Virginia Department of Transportation's Elizabeth River Tunnels and the Transform I-66 Public-Private Partnership, also known as P3 for all of you who haven't heard that, mega projects in Hampton Roads and Northern Virginia, respectively. Nick earned his bachelor's degree in civil engineering from KU in 1983, and he was in my class. He also earned an MS degree in structural engineering from George Washington University in Washington, D.C. He's a registered professional engineer in Virginia and the District of Columbia. Prior to his current work, Nick was appointed Chief Engineer and Deputy Director of the District of Columbia Department of Transportation in 2010. He served in that position for 4 years, overseeing major programs and projects, including the 11th Street Bridge Design Build project and the 8th Street Benning Design Build streetcar project, as well as major bridge rehabilitation projects and urban streetscape improvements throughout Washington, D.C. Prior to that, Nick served as the Regional Transportation Program Manager in charge of the Virginia Mega Projects Program, overseeing P3 projects such as I-495 hot lanes, the Dulles Rail Corridor improvement. That's a big deal for us who travel back to Washington, D.C. So Nick got it off to a great start. And as manager of the Woodrow Wilson Bridge Improvement Project for the Virginia Department of Transportation. These projects were recognized as some of the largest, most complex transportation infrastructure projects in the nation at the turn of the century. Nick's body of work includes over 34 years of public and private sector transportation improvements. Under his leadership, the Woodrow Wilson Bridge Project and the Virginia Department of Transportation received the 2008 ASCE Outstanding Projects and Leaders, that's known as OPAL, Award, the 2008 American Association for State Highway and Transportation Officials, also known as AASHTO, America Transportation Award, and the 2009 International Bridge Conference Gustav Lindenthal Medal. Nick was also recognized in 2010 by AASHTO as a trailblazer in civil rights for his innovations to achieve disadvantaged business enterprise compliance on the mega projects in Virginia. It's now my great pleasure to invite Ronaldo Nicholson, PE, to present the 7th Annual T.A. Tiberti Family Lecture. Nick?
Thank you. Well, thank you. First, let me thank the Tiberti family, Tito, Tiberti, for this esteemed honor and providing an opportunity for professionals to come back and discuss issues facing today's profession and how, as you say, to inspire professionals to be. Let me also thank Chairman Darwin for your selecting me to give this honor. It's truly an honor. Dean, thank you for the opportunity. And thank you all for allowing me to come to you this afternoon and talk about what is for us all a passion of our lifetime. Some time ago, 35 years to be exact, I was like you. I had just completed a internship with IBM, summer of 1982, where I got the chance to go back and forth to Topeka from Lawrence, spent the summer here. And it was during that time, working as what I would call a systems engineer, I first found out how satisfying it is to solve a problem. The problem of that day was we were going to a manufacturing plant, and if you can believe it, they were running Fortran, and I know that dates me. But the program wasn't working. So they had called out big IBM, and I, being an intern, really was the subject matter expert in the room. I looked at the code. It was obvious to me that they had a couple of colons out of place. Suggested it. They looked at me like, really? That's all? They hit execute, and yes, that was all. It was then that I recognized that solving problems for people was to be what I wanted to do. And coming back, I actually changed my major. I went from the dual major of business administration and civil engineering to civil engineering. Because at that point, I understood that I wanted to be a civil engineer. So that's what I want to talk to you about. Our profession of civil engineering. Now, Chair Darwin gave you all this, but what it doesn't say is that I am a product of what we call back then SCORMABE, Student Council for Recruiting, Educating Minority and Black Engineers. What now that has grown to be NSBE here at the University of Kansas. I was an inner city youth who had an aptitude for math and science. And at that point, what I thought would be the ability to design and build things. So I chose architecture engineering. And within 2 weeks, that architecture engineering professor said, nah, this ain't for you. So I went to see who was then the chairman of civil engineering, Stan Roth. I took a class with Professor Roth, and he basically said, this is what we do as civil engineers. We use math and science to predict and design for the phenomena of the universe to solve those problems. He put me in a survey class, and it was from then on, I was a civil engineer. So let's talk about our profession. Right now, there are about 300,000 plus jobs in civil engineering. It's a good time for you all because in the next 10 years, that's going to increase some 11%. Some 11%. They say that the average salaries are $83,000. Don't worry about salary. Job satisfaction is what will take you. The money will come. Now, I know we all have to pay off everything that you're accumulating now, and you will do that if you work hard. But what I suggest is more important are what I'm showing as your 3 E's. And that's what I really want to talk to you about. I want to talk to you about what are your expectations in the workforce when grades no longer matter, but the work you produce and how you produce it. The expectations in the job. I want to talk about ethics. Why your name as a professional will be so important. How you will have to lead by example. How people will want to be around you because you just do the right thing. Not because it's a lot of legal mumbo jumbo that tells you what to do, because you want to do the right thing. And finally, I want to talk about engineering excellence. Engineering excellence is that what sets us apart from the other professions. Excellence is what we do to go over and above. So those are my 3 E's. And in doing that, I think it's important to understand what got me here. I got about 10 slides. So no one needs notes, because that's just a conversation. What you'll see in these slides are some of the projects that were talked about. And at the end of the lecture discussion, please ask questions, either about the pictures or what you hear and gives you some idea of where we're going. Expectations. You got to pay your dues. I know you're millennials. I got 2 millennial daughters. Both have graduated from college, and their thoughts were they're gonna rocket into the job force, make all this money, make now life decisions, because it's no longer me. They're adults now. You now have to buy your own car, pay your own rent, and I know some of you all are doing that right now. But then there's no one to fall back on. I cut the cord. So when you get out, don't expect to rush to the top. Don't expect because you've made Dean's List and 4.0 that you're automatically going to be at the top, because there are a lot of others that have been at the top, but have proved themselves by providing excellent work, knowing and anticipating how to be successful on a project, in a community, and getting things approved. One of the things I tell a lot of my employees, even today, is the thing called completed work. Completed work is a deliverable that meets the specifications, is totally in line with what was expected from the supervisor, from a local official, elected official, or from you. It's complete. You turn it in to your supervisor, to whomever, not just to say it's done, but it's done with a lot of satisfaction that you put into it. Completed work. And lastly, let's not be afraid to get dirty. Whether you go into the public sector or the private sector, at some point you're going to have to do something the bottom of the totem pole will have to do. And you should look at it and achieve it. I first came out of KU and I took a job with the Federal Highway Administration as a highway trainee. Yeah, you remember now. I took that job not because the salary. It's because coming out of the Midwest, I wanted the opportunity to see the country. So the Federal Highways gave me the opportunity as a highway trainee to travel to California, Colorado, Texas, everything west, see the country. Professionally, I got to build roads through Yosemite Park, Rocky Mountain National Park. It was in Rocky Mountain National Park where another trainee with me, they were building or expanding the road through Rocky Mountain National Park. We had to do it at night because during the day they had 60,000 vehicles traversing the park, and the Park Service, our client, basically says, no, you can't interrupt that traffic flow. So Granite Construction was a contractor. They put up a crusher plant right there in the mountains, made the material, had the trucks, and between the hours when the park was closed of 7 to 7, they built the roadway. Well, one evening, I was out on grade with the nuclear gauge. Am I still dating myself? Yeah. Because we had to ensure compaction. You had to get 95% of Parker as they filled up if they build the embankment. And they were starting to bring in trucks on a real efficient production, really trying to get this done, take advantage of the window that they had. And it was beginning to get concerning to me because I couldn't keep up. And after so long, they're bringing in these trucks, bringing up this field, I finally flagged down my supervisor, and I asked him, what do I do now? And he kind of looked at me with this look like, why are you asking me this? He says, it's pouring down raining. Why do you think you would get compaction in rain? And that was my turn on to think. That was my turn on to say, okay, you will not have all the answers when you get out. You think you do. Carrying that nuclear gauge around in the rain, thinking that I could inspect and certify an embankment was not my smartest moment. But what I did take away is when you don't know, you ask. And by me asking, I learned something very important. That even as an inspector, I'm empowered to dictate what happens. So I stopped the trucks, told that foreman, who kind of looked at me and said, yeah, I wondered when you was going to say something, and move on. But my point is, you're going to be given tasks where you're not sure, and rather than get a moment, ask. Ask the questions. All of you all should set goals when you come out of KU. For me, it was a 5-year goal. Where do you want to be 5 years from the time you graduate? You may choose to be in the public sector, private sector. You may serve your country in the military. You may continue in school. But you need to look at what happens 5 years from now, and then move up and do things to meet those goals. One of those things, and I hope, as it was for me, you take your EIT or fundamentals while you're in school. Why? Because now you have a routine of solving problems. You have a routine of answering problems. You get out of KU, you get out of school, and that no longer is automatic. You have to relearn that, which makes that fundamentals test so much harder. And then you document your experiences with whomever you're with so that you can apply and sit the PE exam. Now, you may not want to practice engineering. You may want to be in construction, so there's an exam and a certification for that. You may want to be in marketing. But whatever you decide to do, you need to set that goal. Look at what you need that sets you a point that when someone looks at your name, they say, that's a professional. And whether it's construction, engineering design, even project management with the PMP, make sure that you go towards those goals. Your name means something. Again, I'm not going, how many lawyers in the room, first of all? Let me understand who I'm talking to. No lawyers, okay. There's a thing. We solve problems, and we try to solve the problems before it gets to the attorneys. When it gets to the attorneys, you find yourself in a room with 2 or 3 of them, and what I have found, if you get 2 or 3 attorneys, lawyers in a room, you'll get 2 or 3 opinions. None of them will be the same. And they will look back to you as the engineer to say, well, what's next? So don't let it get to them. Find a way to resolve the problem, whether it's a claim, dispute, whatever, with engineering. 1 and 1 equals 2. It's that simple. That's how we keep it simple. So your name means something. When you say you're going to do it, do it. What makes it different as an engineer, they expect you to be right. We're not weather forecasters. We interpret things based on math and science, sometimes to 2 or 3 decimal places, depending. So you want to keep your name pure, because that's your reputation that goes forward. I said this before, you got to do what's right. You will find yourself in situations as the expert in the room, and you will have to make decisions that affect communities, that affect people's lives. As a civil engineer, as an engineer, we're putting positions where we can define how people get home from work each day. What's their commute? We draw lines, not on plans anymore, but on the CAD system that basically say this business, and that business has to be relocated. You have to be able to articulate why. You have to give sound reasoning on why that line should be to the left or to the right. And it's based on things that are for the good of all. Right now, Puerto Rico has lost their electrical grid. And it is very important that whoever replaces that not only looks at the immediate, but also in the future. What's in the news right now is that has been provided to a sole source contractor with little understanding. Ethically, is that right? Would you want to have your name in the paper next to it? Well, that's the place you may be in as the engineer of record. One of the first things I was taught when I started getting in front of the public, if you can't say it and have it in the media and be able to go back and tell your family and those you love why you said it, then maybe you shouldn't say it. But that is our responsibility as professionals, to be right, to be fair. In ethics, we're going to distribute work. On the public side, you're going to give out contracts or have some function, some level of involvement of doing that. On the private side, you will be seeking contracts, be seeking work. If you're giving out major, whether it's $10,000 or $200 billion, you need to be fair. There are codes, there are requirements, there are processes in the public sector that we follow that checks the box all the way. And that's what the public sector does. It doesn't look for efficiency. We're bureaucrats. But we're there because we take care of the taxpayers' money. So yes, we will dot our I's and cross our T's to make sure it's fair. We'll make sure it's diverse. We'll make sure that these contracts, these opportunities go to not just those that have always had them, but also to those who may have not, to give them an opportunity to take that contract and go to the next level. But that's also needed on the private sector, because as you get that contract and perform those tasks, you have to make sure you do it in an equitable and fair way. you have to make sure that the work you turn in is worth every dollar that you say it's worth. Completed work, meeting those expectations. Those things will carry you throughout your careers. One of the other things that I also profess, and I'm a project manager. As you see, I'm a bridge engineer. But I'm also an advocate for the projects that I do. If you, just like when you're in groups now, you have to advocate for your project to be successful. If you can't do that, then you need to change the scope or whatever it is about the project. If you can't go out and speak to a community and speak to elected officials about why this project should be done this way, then you need to rehuddle your team as a professional and say, what are we doing wrong? Projects, especially civil engineering projects, whether you're distributing water, whether you're finding new ways to convey energy, they affect the quality of life for the people around you. All the time. We've been doing this for centuries. And what makes it so particular now, as was said with the stats before, our infrastructure in this country is failing. And it's going to be you, us, that make it there for the next generations, for your sons and grandchildren that will be looking at how to get from A to B and how they will get clean water in the future. So we want to do it right. And I have to talk about public safety. As engineers, we should put safety in everything we do. You should make sure that you have your PPEs, personal protective equipment, whenever you enter a work zone, whenever, as the chairman says, you enter the laboratory these days. Put safety in everything that you care about. So why not do it in the workplace? We have to think about the traveling public in transportation. We have to think about the workers who build our projects on construction sites. We want to make sure that everybody that comes to work goes back home because they have families too. And as the engineer, the resident engineer in charge of that construction site, that's your responsibility. That's your profession. Those are your expectations. And the ethics of that is that you know it's important and you prioritize it. So you have the daily toolbox discussions when you start the day. You count everyone that goes in a tunnel to make sure they come back out. You make sure all the signs are up on a lane closure as you go in and out of a work zone. Because there are standards out there to say what we should do and how we should do it. Those are the expectations. Those are the ethics. And now let's talk about engineering excellence. What defines excellence? Quickly, they would say, is your project on time, on budget? That's the quick one. But there's a third leg to that stool, and that is your scope. And on top of all of that is quality. It's easy to say, yes, I'm on time. Yes, I met my budget. But it won't last a year. When your project, a major infrastructure project, or even something you do at home, when you put time and effort into it, and it doesn't give you the results that you're looking for, you haven't provided quality. Quality is that term that you just don't do it for this, but you develop a process that makes sure that things are checked. As a professional, you do your due diligence to make sure that you research that the problems that have occurred before don't happen again. You understand and be able to predict, model what will be the impacts of a project. I mean, we put out there life cycle costs, but many times we stop the costs when the project is done and then allow somebody else to maintain it. Well, now we have things called resiliency, sustainability. Those are the new words in the profession where we're looking for the projects and our deliverables to be sustained, to last not just the 20-year service life, but be maintainable during that 20 years. That's engineering excellence. Those are our expectations, and ethically, that's how we should be designing our projects. Professionals are just that. We have education behind us, experience, and we make sure when we sell a product that is done right. We have to protect our environment, and I know I'm singing to the choir when I say that, but so many projects, so many times we look at how we can get something done quickly, cut corners, and allow that sediment to just roll off the project into our streams and rivers. I used to talk about my grandmother, who's from Arkansas. And she would go in a family's home and basically look at their kitchen and determine how they keep their home. She says, if your kitchen's dirty, you don't keep your home right. Watch using the bathroom. Well, it's the same way on a construction site. When you go on a construction site and you see materials everywhere, no clear ingress and egress, you see all the roadways with soil, contaminates and everything, it tells you that that superintendent has not upkeep that construction site, which means you're not protecting the environment, which probably means you won't have a sustainable end product, which probably means that you didn't meet the expectations of that client. All these are linked. We're leaders. And there's a statement that I call situational leadership. It's in all the Covey books and those on business administration, but what it means in the engineering workplace that sometimes you will have to lead. And whether that's a design team, whether that's a team out on a construction site, or whether it's just somebody in the truck carrying around a new, you will have to lead. But you will also have to follow. And knowing how to follow means that you just understand what the leader has told you. If you disagree, say why you disagree. Point out your perspective, but have a constructive dialogue. Too many times, us as young engineers, especially us as minorities, we won't speak up, even though we know we're right. That's just as bad as being wrong and being very loud about it. Just as bad. So we need leaders in our profession to meet those expectations and those ethical requirements to achieve engineering excellence. We need leaders that won't just go the way because the boss said, but will let the boss know, hey, there's another perspective. There's another way to do it. Young structural engineer. I was with Tito, a bridge engineer, federal highways, Albert Abiasi. Still can't say his name. He had been there some 40 years and had his way of doing things. Well, I'm this young, aggressive engineer coming out, basically says, hey, we did it this way in class. He said, no, you have to do it this way. I'm saying, but that's a long way. We did it this way. No. He's my boss. So I did it his way. But then after hours, stayed out and showed him that I can get those same answers my way. Went back to him, said it. He said, Mr. Nicholson, you just showed me there's more than one road to Rome. Don't be afraid to show what you know. Don't be afraid to be innovative. Your minds, your millennial minds, will be what take us into the future. What we did with our work previously, yes, it's got us here, but we need that next generation of professionals that's going to take us to the next level in our infrastructure. What happened back in the Egyptian times, we can't recreate. But we do need you all to rebuild our ports. We do need you all to determine a way to fix our bridges, sustainable bridges. We need those leaders that's going to take us to the next level in our profession in engineering. My last point on engineering is communication. Not just project application, but just to articulate the advantages and the benefits of what we're providing. At some point in your career, you will take Myers-Briggs indicators, which is going to tell you how you receive information and how you interpret that information when you receive it. The first ones are E and I, extrovert and introverts. As a profession, they say all of us engineers are introverts. Well, I'm the exception. I'm definitely an extrovert. But they say that because we really don't convey not only our ideas well, but also we don't praise achievements in our industry well. Supervisors don't point out bad work well. We don't praise and we don't discipline. As leaders, we should set those expectations on what we want. Ethically, we should tell the good, the bad, and the ugly. We should manage up, but we should also be able to manage down. No one likes conflict. No one wants to get into conflict. But what we do need to do is, as professionals, convey what's working and what's not. And it will be up to you to do that repeatedly. You will have communities that will basically say that they don't like your ideas. You will have salesmen who say, why won't you buy my product? You will have elected officials who will basically tell you, you have to do this. If you don't do this, I'm blackball your firm. If you don't do it this way, I'm going to speak out against your department. You will be encountering those situations, but I offer to you that the 3 E's, setting expectations, providing ethical discussion to a community, and making sure that we always pursue engineering excellence will carry you through the day. This picture here is an example. That is actually us blowing up an existing bridge in the Alexandria community. At the time, we had been sued by the city of Alexandria for building that bridge because they felt the footprint was too big. They felt that we did not do the environmental studies that we were required to do per federal law, NEPA studies. They felt that we were doing undue harm to the historic Alexandria community by not just building the project, but also how we would remove the existing bridge. Over the course of time, we've turned the page to the point that we convinced them that if you allow us to blow it up, it will lessen the impact on the community. If you allow us to demolish it quickly, it would not impact an adjacent historic cemetery, an adjacent school, because we would reduce the number of trucks that have to come in and out. So, by communicating the benefits to this community, one who didn't trust us, one who at one point was hostile to us, through communication, through interaction, we were able, as a team, to convince them to allow us to do what we do best and engineer a solution. Gaining the trust of your community in your profession, in our profession, is what we strive to do. Before I open it up for questions, I'm going to leave you with a story that was told to me on my last days here at the University of Kansas. It was provided by Professor Lane, and I hope I do him justice in trying to repeat it. But it went something like this. There were 4 engineering students coming back from spring break who stopped at a small farmhouse in those cold days in Illinois. As they went up to the door and knocked, a young mother opened the door distraught. She was distraught because one of her children had cut herself badly and was bleeding. The house was cold because the heating system wasn't working. Little potbelly stove was not conveying heat in the home. She was distraught because the dad had went to seek help but had to walk because the car was not running. So these 4 engineering students from the University of Illinois, one of them took a tourniquet and placed it around the little girl's arm, just a tourniquet to stop the bleeding. The other went and looked at the stove, saw the blockage, began to work on it to try to get the heat to go. The third went back to the car and went to seek the father to basically let him know that he would take the child and or him to get some help. And the fourth student just calmed the room, took the children, took the mom, and said, hey, everything is going to be all right. Through the course of time, the father came back, the mom was calm, the bleeding had stopped because the cut wasn't as bad as it seemed. It was a little girl, so everybody was upset. But they were able to stop the bleeding. In the end, those 4 engineering students solved that crisis. Not by some meticulous innovation, but just applying maybe what they've learned from U of I in engineering school, but just making it better way of life for everybody that we touch. I didn't mean to do that. So I leave you with this. Our profession is one that we solve problems to improve the quality of life for those around us. We do it because we use the phenomenon of the universe of math and science. So we're exact. We build confidence by setting those expectations, treating our profession in an ethical manner, and striving for engineering excellence in whatever we do. With that, I'll take any questions. That's the Woodrow Wilson Bridge, the one that was referenced in the article reading the Opal Award in 2008, Astro Award, and the Lindenthal Medal. It was a $2.5 billion project that I was the project manager with the Virginia Department of Transportation, but it had Virginia, DC, and Maryland as it crosses the Potomac River on the Capitol Beltway, I-495, south of Washington, D.C. It's a bascule span, the largest ever. Bascule meaning it's a movable bridge on an interstate, 4-lane interstate. And one of the requirements was that it be able to provide future fixed rail train transit over it in the future. So that movable span had to be built within a 1/4-inch tolerance. There's a number of superlatives I can continue to go on, but that's the project. Great question. I was a chief engineer. What I would always tell my staff and my boss, the director, is that my job is to give an engineering solution to a political problem. I have not been trained to give you a political decision to an engineering problem. So I kept it, and many of my peers would ask me, well, you can't just keep it as an engineering basis. You just can't keep. But that's what I strive to do. Whenever local elected officials or even congressmen will try to put it in the political arena, I would give them alternatives. If you want that political solution, here it is, these are the impacts. But as the engineer of record, I recommend this because of A, B, and C. And it got me through for 4 years. I came to KU in the summer of 1979 in a minority recruitment engineering program. I was here on full engineering scholarship, and they brought us in the summer to basically demonstrate what college life was like. We took the same college calculus, college physics, whatever was offered, and I think that engineering 191, to show that we could be engineers from an academic standpoint. But what it also allowed us to do was get mentoring, because there were other Scomerby students, or National Society of Black Engineering, what we are now, students, that would coast us to navigate through the issues of college life. A lot of us coming from the inner city that I did, although I was blessed because my dad had went to school, a lot of us hadn't went to college, so we really had no comparison. And being able to talk, compare, seek wisdoms from those Scomerby students who were not just here, but it also graduated and offered us mentorship was a plus. And that program was successful for me because of a number of those things. I went on to be one of those counselors. I went on to be one of those recruiters, and I will always be one of those recruiters for this profession, because they need more of us, not just because we make the salaries that we make, but diversity works. And I didn't hit a lot on what it means to be in a diverse workplace, but having different perspectives in solving community problems is a plus. It's an asset. And when you get different perspectives on how to solve problems, it just works. So that's what Scomerby was in the early 80s. I know it has evolved much, and Andrew, we're looking for you to do great things. As I pointed out, I found my passion. And everyone in this room is going to have to find theirs. I found out that in school, and although I couldn't design a building in architecture, I did all right in calculus and physics. To the point I tutored. And part of Scomerby, I was a physics tutor. So I went out to those that were having problems, and basically one demonstrated that, okay, you got to work hard, but it can be done. You got to study, but it can be done. And you need to figure out what that problem is, calculus, whatever it is, integrate, whatever it may be, and work at it. But as that tutor, I begin to see that many of the problems that we face as students, and I have adjunct at George Mason University also, so it hasn't changed in the 30 years either. It's just confidence. And by the time you show them that they can solve those problems, you build that confidence in every step. The next one, they're more confident in attacking that problem, just like I will attack how I get traffic from A to B quicker. It was the same with how I did that integration problem. And it's very satisfying when you figure out and you draw that box around it and say, yes, this is the correct answer. You're going to be in the community in the engineer. Well, let me back up. It depends on your field of engineering. If you are doing infrastructure projects like these, you will be in the community. You will have to get their acceptance in order to spend $200, $300 million. They're the taxpayers. It's their money. If we go out arrogantly, and at one point in our profession, Tom, you remember, my way or the highway? Well, that doesn't work no more in today's society. They don't allow you to do that. So you're going to be in a public meeting, public hearing situation where, as the professional, you're going to have to communicate, again, the benefits of a project. Why should that community be disrupted for 6 months, a year and a half, so we can widen this facility, so we can build this plant? Why? And you're going to have to be able to articulate those benefits. They may not come immediately, but after we're done, for the good of the whole, whether it's, again, clean water, whether it's maybe able to predict your time from home to work. Those are the benefits that we have to be able to say in very concise manners, and be able to write them too, because written communication has not gone away. Has not gone away. Thank you.